Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will start with another course that is Reactive Streams using Spring WebFlux 5. So let's see the course overview. So we will build our understanding for the reactive streams. We will build reactive applications using Spring WebFlux 5. We will integrate with other services using Spring Web Client, and we will make our application production ready by writing unit tests and integration tests. What are the prerequisites? So one must have a fundamental Java concepts and the understanding of Spring framework. The supported versions of Spring Boot is 2.0 to 2.7.10 for this course. Similarly, for Spring WebFlux, it's from 5.0 to 5.3, and for Java, the supported versions are 8 till 17. So before starting with the reactive programming, let's talk about the imperative programming first. So suppose we have a user who wants to access or process the data. So in order to do that, we need to write a method that will connect the data source. So we have a set of instructions for the connection with the data source. Now, the moment the connection is established with the data source, the code execution is blocked. The thread goes into the waiting state as this is an input output operation. Now, once the data is returned from the data source, the code execution is resumed. Right now, the code can do some other operations, like it can perform filter operations on the data retrieved from the data source and might process the data to finally return it to the user. So how we can improve this code execution, mainly the blocking nature, as the reactive programming is based on the three aspects. First is non-blocking asynchronous components, second data streams, and third functional programming. First aspect of the reactive programming, that is asynchronous non-blocking components. So in reactive programming, the threads are not blocked when there is an input output operation or when there is a blocking code. The code execution is asynchronous in nature. So once there is an input output operation or a blocking code, the thread can do some other tasks while waiting for the result from the data source. So as soon as the connection is established with the data source, the thread does not wait and executes some other operations. And in that way, the method or the code is non-blocking. And once the data is returned from the data source, the thread can resume the execution of this code from there onwards. And also, the data is not returned in bulk from the data source, it's decomposed and returned in the form of data streams. To handle the asynchronous code, we might use futures and callbacks, but we can easily fall into a error of callback hell and blocking the futures. So the third aspect of reactive programming, that is functional programming, is used. We have changed our imperative code blocks into functions and we have chained them to get the desired result. As you can see, the filter process return is chained together. Now, what are the use cases of reactive programming? So the major use cases of reactive programming is input output operations. So the architecture or the system design where there is heavy input output operations such as interacting with the databases or calling or integrating with other services. Second, in the modern day world, mobile uses or integrates with different services to render different interfaces. So in that case, reactive programming fits. Third is Internet of Things. So Internet of Things, we are dealing with data that can be well modeled by using event streams such as sensors, outputs, and triggers. So naturally, reactive programming is a good fit here as well. So what is Spring WebFlux? WebFlux is built on different layers. So the lowest level or the slowest layer is reactive programming. So reactive programming is nothing but a set of principles. It has no standards or the implementations. The standards is defined by the reactive streams. So reactive streams defines the standards for asynchronous stream processing defined on the reactive streams.org. So it has mainly four components. First is publisher, which publishes the data in the form of data streams. Second is subscriber, which subscribes to consume the data of the data stream from the publisher. The third is the subscription, which joins the publisher and the subscriber. And the fourth is the processor, that is a combination between publisher and a subscriber. The processor uses a subscription to subscribe to a publisher to get the data from the data stream, and one or more subscriber can use a subscription to get the data from the processor. The standard defined by the reactive streams uses a push model to push the data of the data stream from publisher to the subscriber. So there is a feedback loop from the subscriber to the publisher, which moderates the rate at which the publisher is pushing the data. It can notify the publisher to decrease or increase the rate at which it has to push the data, and that what is called the back pressure. The back pressure can be applied between the processor and the publisher, and the processor and the subscriber as well. Now, what is Project Reactor? Project Reactor is a library which has all the implementations of the standards defined by the reactive streams. So it has majorly two components. One is types and other is operators. So in the types, it has majorly two types, that is mono and flux. And the operators, there are many operators like dot filter, dot map, etc. So we will see many of the operators in the upcoming slides. So let's see the first type of project reactor, that is flux. So flux is a flux of data that emits certain types of signals. So once a connection is established between the publisher and the subscriber, on subscribe signal is sent from the publisher to the subscriber, and then publisher starts sending the data to the subscriber. So when the publisher sends the first data, a signal on next is sent from the publisher to the subscriber. Then the publisher sends the second data, and a next signal on next is sent from the publisher to the subscriber. And then third data that is sent from the publisher to the subscriber, and then on next, again the next signal on next is sent from publisher to subscriber. And if all the data is sent from the publisher to the subscriber, then finally a signal that is on complete is sent from the publisher to the subscriber. Similarly, for the mono, once the connection is established between the publisher and the subscriber, the on subscribe event is sent, or on subscribe signal is sent from the publisher to the subscriber. Now publisher can start sending the data to the subscriber, but for the mono there is only one data that can be sent from the mono publisher to the subscriber. So there will be only one signal or one on next signal from publisher to subscriber, and finally there will be a complete data that is sent from publisher to the subscriber, resulting in on complete signal. Now suppose once the connection is established between the publisher and the subscriber, and then on subscribe signal is sent from the publisher to the subscriber, publisher starts sending the data. So the first data is sent from publisher to the subscriber, then on next signal is sent. The second data is sent from publisher to subscriber. This means on next signal is sent. And finally, suppose there is a network failure. Now the publisher sends an or error signal so that the subscriber can gracefully handle the error. Now we will talk about Spring WebFlux. So Spring WebFlux is at the top layer of the project Reactor, reactive streams, and reactive programming. It's a combination of all the things that we have studied so far. It uses all the concepts and the standards and the implementation defined by the project Reactor or the reactive streams, and it brings into the Spring.io. So the WebFlux has two components. One is web, that is already there in the Spring under the module Spring MVC, that is built on the servlet API, which has the web capabilities in a blocking fashion. Now, to have the non-blocking capabilities, the WebFlux uses Project Reactor implementation, which is built on the reactive stream standards, not on the servlet API. How we decided to come to use reactive programming? So in the past, when there was a monolith application, so there was minimal IO operation with the DB or with other services. Now in microservice architecture, we have numerous of input output operations or numerous of input output interactions. Here there is a need of reactive programming.